The next piece we want to look at is determining the domain and range of a function. And when we do domain and range, we're going to write our answers in interval notation. So a quick review of what interval notation looks like. First of all, there are really two pieces you work with interval notation. The first is a parenthesis, the second is a bracket. A parenthesis indicates an open interval, which means if we were to graph it on the number line, we would have had an open circle. The bracket represents a closed interval, or a closed circle on the number line. So if for some reason I wanted to graph x is greater than 3, back in the old number line days, you would go to 3. Since this is greater than 3, you would put an open circle on 3, and then shade everything that was larger than 3. Now that we're dealing with interval notation, we are going to write it in terms from 3 to infinity. So since this 3 is an open circle here, that's an open interval, we're going to use parentheses. So this is going to be written 3, comma, infinity. We have our starting value, what we're going to end up with, and with infinity, we always end infinity with a parenthesis sign. If I had something on the number line, such as a closed circle at -4, all the way to a closed circle at 5, and my interval was from -4 to 5 with the closed circles, I would have bracket -4, comma 5. Brackets on both sides indicating it's a closed interval. If I had the entire number line, so all real numbers, I go from -infinity to infinity. So that's just a quick review of what our interval notation is going to look like. And when we write our domain and ranges, we're going to want to use interval notation. Second thing here is a brief review of finding the domain. What are two things that we explicitly look to exclude from the domain? And there are two things. The first thing are zeros in the denominator. We can't have zeros in the denominator because anything divided by 0 is going to be undefined. Second thing is negatives underneath square roots. Negatives underneath square roots yield imaginary numbers, and we're dealing with the real number plane when we're finding our domains and ranges for our equations. So here we want to look at and finding the domain and range for each of these graphs. So the first one, f of x is equal to 4x squared minus 3. Now this one is going to help us by graphing it out. So we want to look at the graphical perspective of this. 4x squared minus 3, that's a skinny parabola that is 3 units down. So it's got this sort of skinny parabola here, 3 units down. And I look at that equation, and we'll start with the domain. Is there anything that makes a 0 appear in a denominator, or anything that would cause an imaginary number? And the answer is no. I've got no denominator, so I don't need to worry about that. I've got no square roots or anything that would produce imaginary numbers. So I can plug in any real number, and I'm going to get an answer out. So my domain goes from -infinity to infinity. I could plug in a 3, a 4, a 9, a -5,000. I could choose any number and plug it in and get an output. The range, if we look at the y values, the absolute minimum right here is that point at 0, -3. Range, we're dealing with y values, so we're going from -3 up. So I'm going to include -3 and go up to infinity. So my range, -3 including -3 up to infinity. The second one, h of x is equal to x squared minus 1 over x plus 1. This one, if you look at it, you probably won't know what that is right off the bat. But you do know one thing. You do know that we could get a 0 in the denominator. So we know here x cannot equal a -1. Because if I plug in a -1 right there, -1 plus 1 is 0, 0 in the denominator. Can't have that. So we can find the domain pretty easily. The domain is going to go from -infinity to -1. And then we're going to union that with -1 to infinity. That union is just a way that we can join two domain pieces together and exclude a value. So this is saying we're just excluding -1 because we've got the parentheses on both of those. The second part then is finding out what is the range going to be. And if I graph this out, you might think this is going to be a parabola because that x squared, but x squared minus 1, remember that factors down to x plus 1, x minus 1, and we've got x plus 1 in the denominator. So my x plus 1's cancel out, and I'm really just left with this x minus 1. So my y-intercept right there is at -1. And then my slope is 1 over 1 up. So 1 over 1 up, 1 over 1 up. And then same thing in the other direction. The one thing we have to look out for, though, is the fact that this -1 was an issue. So when that cancels out, I'm going to have a hole over here. And the way I find that hole is I plug my issue value into my simplified version. So -1 minus 1 gives me a -2. So I'm going to have a little issue at -2. So my range for this equation here is going to be from -infinity all the way to -2, unioned with -2 to infinity. Once again, we have to exclude the value that's in our hole right there. Looks like it's a straight line that goes on forever, but remember that point is undefined.